Thank you. Thank you. Good morning, dear students. So today's topic we are going to discuss is redox reaction. Yes. So what are redox reactions? Okay. So we'll start with the topic. What are redox reactions? So redox reactions are nothing but these are the reactions which involves oxidation and reduction simultaneously. Okay. So the reactions which involves oxidation and reduction simultaneously are nothing but redox reactions. So there are different definitions which are given for oxidation and reduction. So we'll see one by one. So the first is in terms of oxygen. Okay. In terms of oxygen, what is oxidation? So whenever you are adding of oxygen, okay, or addition of oxygen is called as oxidation. So, and what is reduction in terms of oxygen? When you are removing the oxygen, okay, so removal of oxygen is called as reduction. Then in terms of hydrogen, what is oxidation? When you are removing atom of hydrogen, okay, when you are removing hydrogen, it is nothing but it is oxidation. When you're adding of hydrogen, okay, when you're adding a hydrogen, it is reduction. Then in terms of electronegative element, okay, in terms of electronegative element, what is oxidation? So whenever you are adding a electronegative element, it will undergo oxidation. And similarly, when you are removal of electronegative element, okay, removal of electronegative element is nothing but your reduction. Then in terms of electropositive element, removal of electropositive element is your oxidation and addition of your electropositive element is your reduction. Then in terms of electrons, okay, in terms of electrons, which is very important, okay, electrons, loss of electrons is said to be oxidation. So a reaction in which there is a loss of electrons is a oxidation. And whenever there is gain of electrons in the reaction, then it is reduction. Then in terms of oxidation number, okay, increase in oxidation number is oxidation and decrease in oxidation number is reduction. So now what is this oxidation number? So you need to remember all these definitions. Okay. So next is what is oxidation number. So it is nothing but it is the actual charge or the apparent charge on an atom. Okay. On an atom in a compound. So this is nothing but your oxidation number. So it is the actual charge which is present on an atom in a compound. Now, what are the rules for calculating this oxidation number? So there are some rules which you need to keep in your mind. Okay, so that will help you for calculating the oxidation number. So the first one, elements in free or uncombined state will have oxidation number. Okay, 0. It will be 0. So elements in free or uncombined state will have oxidation number of 0. So free means what? Elements in free state means example, sodium, magnesium, aluminium. Okay, aluminium. So these are elements which are in free state. So this will be having what will be the oxidation number? It will be 0. And whenever you have in uncombined state, okay, now this is what? These are diatomic molecules. You can see. So that is hydrogen, H2 molecule, O2 molecule, Cl2, okay, and O3. So these are having oxidation number 0. So this is the first rule. Second, ions composed of only one atom. Okay, ions composed of only one atom. So oxidation number is equal to the charge of the ion. So for example, Na+1. So what is the charge here? +1. So this is nothing but, so the oxidation number is equal to the charge of the ion. So the ion, what is the charge? It is +1. So the oxidation number is also, it is +1. For Mg+2, what is the charge? It is +2. What is the oxidation number? It is +2. Then Fe+3, the charge is +3. And what is the oxidation number? It is +3. So this is your second rule. Then oxidation number of oxygen in most of the compounds is -2. Okay, so in most of the compounds, when you are seeing the oxidation number of oxygen, so it most commonly occurs as -2. Only the cases is in peroxides and superoxides. Okay, in the case of peroxides and superoxides. So what are peroxides? What are peroxides? What are peroxides? Can you tell me what are peroxides? For example, peroxide, I can take example of H2O2. Okay. Now in this H2O2, what is oxidation state of oxygen? You know. Now hydrogen. Okay, hydrogen. What is its oxidation state? It will always occur as +1. Okay. So most commonly it occurs as +1. So hydrogen +1. So there are how many atoms of hydrogen? 2 atoms. So this will be +2. Okay. So each hydrogen it is +1. So how many oxygen are present here? There are 2 oxygens. So each oxygen it should be, so this is +2. The overall charge on H2 will be +2. So to make this compound a neutral, okay, it should be 0. So each oxygen will be -1. So your exception case is when it is peroxides. Okay, when oxygen is in the form of peroxide, the oxidation number is -1. What is superoxide? Superoxide, for example, KO2. Okay, KO2. What is this K? K is nothing but your potassium. Okay, potassium. What is the oxidation state? What is potassium? It is a alkali metal, right? So alkali metal. So this potassium, always alkali metal, in which state it will be? It will be in +1 state, right? So now to overcome, so always you know, this will be overall charge on this particular compound will be 0, right? So to make this 0, there are how many oxygen atoms? 2 oxygen atoms. So how you will divide it? So each oxygen atom will be -half. So -half will be -1, right? So -1 + 1, the overall charge will be 0. So you can see in superoxide, the oxidation state is -1. So this is the oxidation number you have to calculate. So so most commonly it will be in what? It will be in -2. Oxygen will occur in -2. Only the exception cases where peroxide will be -1 and in superoxide will be -2. Then oxidation number of hydrogen in +1. So you know, most of the cases this oxidation number of hydrogen is +1. Only exception is in metal hydrides. Now metal hydrides, for example, I'll take as NaH. Okay, what is Na? Na is sodium. Sodium is a alkali metal. What is the oxidation state of sodium? Sodium will be +1, right? So most it will readily give 1 electron. So it will be always in the +1 state. So to make this overall compound 0, this will be -1. So metal in only when hydrogen it combines with metal, the oxidation number will be -1. So this is the exceptional cases, but most commonly it will occur as +1 only. Then oxidation number of fluorine. Okay, fluorine is what? It is halogen, right? So it is a halogen. So oxidation number of fluorine is -1. And other halogens like chlorine, bromine, iodine will also have oxidation number of -1. So these are some of the these are some of the rules to find out the oxidation number. Now we'll see how to calculate some of the oxidation number of some important compound. Okay, now Cr. Just a second. So here Cr, okay. Cr in, what is the oxidation number of Cr in? CrO5. Now Cr, so first we'll write the structure. So it will be Cr, okay, the structure of this particular compound is okay. So like this is the, it is the structure of this compound. Now how to find, so this Cr, so this you have to keep it as X, okay, X plus. Now how many oxygen atoms are involved? So this is what oxygen atom. So this oxygen atoms, how many are involved? Now this is what this is having. You can see this is a peroxy linkage. Okay, peroxy linkage is present. So out of this, how many are there? 4. So you have to calculate this as 4 into -1. Okay, -1 plus how many? 1 into -2, right? Equals to 0. The overall charge will be 0. So x -4, this is -2 will be 0. So x is equals to 4. Okay, so x is equals to x minus 6 is equals to 0. So x is equals to 6. So the charge of Cr is 6. So why we have taken this oxygen as -1? Because this is a peroxy linkage. Okay, you know, in hydrogen peroxide, what it will be? It will be like this, right? So this is the way you have to calculate the oxidation number, okay, of Cr. So you have to substitute all the given values. So we'll solve the next one. So here H2. So you have to find out the oxidation number of S in H2, S2O8. So H, so S, okay, S. So how many S are present? Right? So 1, 2, 3, 4, 5, 6, 7, and 8. So this is the structure of H2S2O8. Okay. Now find out what you have to find out, the oxidation number of S. So S oxidation number. So how you will write it? So H2S2O8. So hydrogen, commonly how it occurs? It occurs as +1. So how many atoms are there? 2. So 2 into 2 into 1 plus, okay, how many sulfur atoms are there? 2. So write it as 2x. Okay, plus how many oxygen are there? 8. Out of 8 oxygen atoms, how many are peroxy linkage? Here 1, 2, 3, 4. So you write 4 into -1 plus, okay, plus how many are, so these are 4. So 4 into -2, right? Equals to what? It will be 0. So solve it. 2 plus 2x minus 4 minus 8 equals to 0. Okay. So this will be what? 2x, right? 2x minus 10 equals to 0. X equals to 10 by 2. So it will be what? 5, right? So like this, you have to calculate the oxidation state. So next we'll see so redox titration. So you have heard the word titration. What do you mean by titrations? Okay, you have studied about acid-base titration. Acid-base titration is nothing but acid. So one, there will be 2 solutions. Okay, in titration, 2 solutions will be taken. One will be a acidic solution. One will be a basic solution. So what will be there? What will be the main aim? So out of 2 solutions, one will be of known concentration, another will be of unknown concentration. So by titrating the known, taking the unknown against the known solution, you are going to find out the concentration of the unknown, right? So whenever these titrations are carried out, so in acid base, both solutions will be colorless. So you are going to make use of an indicator, right? pH sensitive indicator. Now this is called as redox titration. So in this redox titration, same again 2 solutions will be taken. So but in redox titration, one solution will undergo reduction and another solution will undergo oxidation. So this is one of the example is KMNO4, where you take KMNO4 titrations. Okay, KMNO4 titration in acidic medium. So KMNO4 solution is a dark purple color solution. Okay, so this usually you titrate it against the FAS. So standard solution of FAS is taken and you are going to titrate it against ferrous ammonium sulfate. So now KMnO4, as it is dark color solution, so it acts as a self-indicator. Okay. So to indicate the color change, KMnO4, it acts as a self-indicator. So the molecular equivalent mass of KMnO4 is 31.6. So like this, and this KMnO4 is a strong oxidizing agent. So this plays a very important role. So KMnO4 titrations are important titrations. So next is K2Cr2O7 titrations. So K2Cr2O7 is what? Potassium dichromate. So this potassium dichromate, when it is taken in acidic medium, same, what will happen? In redox reactions, one will undergo oxidation, another will undergo reduction. Okay, by titrating the known against the unknown, you are going to find the concentration of unknown. So here the indicator is used. Okay, here there is no, it is not acting as a self-indicator. It has not so dark color solution. So this is indicator. Why it is indicator is used? Indicator is used to show the or to determine the color change. So the indicator uses diphenylamine. Okay. What is the equivalent mass of K2Cr2O7? It is 49. This K2Cr2O7 is also a strong oxidizing agent. So redox titrations are nothing but titrations are carried out to find out the concentration of an unknown solution. So in redox titration, what is the two solutions which are used? One will be oxidation, it will undergo oxidation, and another will undergo reduction. So what is the role of oxidizing agent? Oxidizing agents are nothing but it oxidizes others. So this K2Cr2O7 and KMnO4 solution, that is potassium permanganate, potassium chromate, dichromate, these are a strong oxidizing agent. Strong oxidizing agent means what? Oxidizing agent means what? It oxidizes others. Okay, it oxidizes others and itself undergoes reduction. What do you mean by reducing agent? Reducing agents are nothing but it reduces others and itself undergoes oxidation. Okay, so remember this definition. So based on this, we'll solve some questions. Which of the following process takes place in oxidation process? Okay, which of the following process takes place in oxidation process? Addition of oxygen, addition of hydrogen, removal of oxygen, addition of chlorine. Yes, which is the correct answer based upon the definition? What is addition of oxygen? Yes, yes, A. A is the correct answer. Good. Okay, so A is the correct answer. It is addition of oxygen is your oxidation. Addition of hydrogen is what? It is reduction. Removal of oxygen is reduction. The other addition of chlorine is also reduction. So this is the correct answer. So next, given reaction 2K4. So this is a complex. Okay. So potassium ferrocyanide. So this is it reacts with H2O2. It is a peroxide and it gives you K3FeCN6. Okay. Plus 2 KOH. The above given reaction is oxidation reaction due to. Yes. So based on the definition, can you tell me by seeing the reaction, just see which of the answer is applicable. Okay. Which of the option is applicable for this? In terms of oxidation and reduction, they have asked, this is the given reaction. They have asked above reaction is oxidation reaction due to. What is the reason? What may be the reason? A, removal of a hydrogen from H2O2, addition of electropositive potassium to H2O2. Okay, these two are subscripts. Okay, H2O2. Then removal of electropositive element potassium from potassium ferrocyanide K4, FeCN6. All of the above are correct. So what is it? Yes, you can see there is a removal of electropositive. All right. So answer is second, this third one. Okay, C, removal of electropositive element is not from K. So here it is K4. Here it becomes K3. So there is a less. Okay, one electropositive element has been removed. So the correct answer is C. So it is from the definitions. Next, in the reaction given below, identify the species undergoing redox reaction. So the reaction is 2Na plus H2 gives you 2NaH. So I have given the rules. Okay, based on the rules, substitute the oxidation. First thing what you have to do, you have to substitute the based on the rules, write the oxidation states or oxidation numbers of this Na and H2 and NaH. Okay, and then you see which is undergoing oxidation, which is undergoing reduction. Yes. Two Na S H2 G giving you 2 NaH. Okay. So Na, it is free. So it will be 0. H2, the oxidation number will be 0. So this is what? +1 and -1. Yes. What happens? What is the correct answer? So what will happen here? So 0 to +1, there will be increase in oxidation number. So this is undergoing oxidation. And 0 to -1, reduction. Yes. So what is happening here? Na is getting oxidized and hydrogen is getting reduced. And Na is undergoing oxidation and hydrogen is undergoing reduction. The correct answer is D. It is both B and C. Okay. Na is getting oxidized. It is getting oxidized and hydrogen is getting reduced, as well as Na is getting oxidation. Oxidation means what? It oxidizes other and itself undergoes reduction. So this is the correct answer. Okay. So next. The loss of electrons the loss of electron is termed as oxidation, reduction, combustion, or neutralization. Loss of electrons is what? It is A, oxidation. Correct. Okay. Correct. So it is oxidation. In the following reaction, which is the species being oxidized? Okay. So in the following reaction, which is the species being oxidized? So see the charges. So this is Fe plus 3. Okay. What is the reaction? 2 Fe plus 3 plus 2 gives you I2 plus 2 Fe plus 2. Okay. Now what is the we'll see with respect to oxidation number. So Fe from +3, it is becoming +2. So there is a decrease in oxidation number. So decrease in oxidation number is what? Reduction. Okay, so this is -1. From -1, it is going to 0. So this is oxidation. Okay. So oxidation, increase in oxidation number is nothing but your oxidation, and decrease in oxidation number is reduction. Now what is asked? Which is the species being oxidized? Which is the species being oxidized? So I minus is what? It is oxidized to I2, right? So which is the species? It is I minus. So the correct answer is I minus. Understood? Yes. So this is all based upon your definition. So you have to keep all the definitions in mind. Okay. So based on these definitions only, the problems are asked. So next, which of the following reactions depicts the oxidizing property of SO2? So which of the following reactions depicts the oxidizing property of SO2? So what you have to do, you have to find out the oxidation state of S in all. Okay. So now you see there is what happens here. So S. Now each oxygen, you have to write the oxidation state or oxidation number for each. Now here, each oxygen is what? -2. So this will be -4. Okay, this will be -4. So this will be -4. So the charge will be here +4. Then here, each hydrogen will be +1. So it will be +2. Then each oxygen will be -2. So into 3 will be -6. Okay, I'm calculating for overall oxygens. Don't get confused. Each oxygen will be -2. -2 into 3 will be -6. You have to see that the overall charge will be 0. So now this will be what? It will be +4. So is it going change in this? No. So it is from +1 to +4 only. Then next H2S. So this will be +2. Okay, this will be -2. So you have to see for SO2. So this is -4. Each oxygen is -2 into 2 will be -4. This will be +4. Okay. Then here sulfide is 0. So here it will happen. What will happen? Just see here. So there is a change in oxidation, right? There is a change in oxidation number. We'll see another all also here. So this is also +4. So this is what each chloride is -1. You know, Cl is -1. There are 2 Cl, so it will be -2. Each oxygen is what? -2. This is -4, right? So here what it will be? Okay, so here what is happening now? Next, here SO2. So here it is plus. So write the oxidation number for all. Okay, this is +4. Here it will be the overall charge. So how to calculate SO4 -2? Okay, so here it will be X plus 4 into -2 equals to -2. So X minus 8 equals to -2. So it will be 6. Okay, so it will be +6. So what is happening? The correct answer is B, because SO2 is getting what? It is getting oxidizing property, right? It oxidizes other and itself undergoes reduction. So it is getting reduced. So this is the correct answer. So which of the following reactant depicts the oxidizing property of SO2? Okay. So in this case, what it is increase. There is increase means what? It is going reduction. So it is reducing other and itself undergoing oxidation. So this is the correct answer. So what is happening? SO2. What you have to what is asked? What is which of the reaction is showing or depicting the oxidizing property? Okay, so SO2. SO2, what it is doing? It is a good oxidizing agent. What do you mean by oxidizing agent? It oxidizes other and itself undergoes reduction. So there is reduction means what? Decrease in oxidation number. So the correct answer is second one, B. Next. Which of the following statement is not correct? Okay, potassium permanganate is a powerful oxidizing agent. Potassium permanganate is a weaker oxidizing agent than potassium dichromate. Potassium permanganate is a stronger oxidizing agent than potassium dichromate. Potassium dichromate oxidizes a secondary alcohol into ketone. Yes, which is the not a correct statement? The correct statement is which is not a correct statement? It is B. Okay, potassium permanganate is a weaker oxidizing agent. No. Okay, it is stronger oxidizing agent than potassium dichromate. Okay, so B is the correct answer. The reaction of KMNO4 and HCl results in, okay, KMNO4 and HCl. So we'll write the reaction first. So I'll write the reaction here. So it will be 2KMNO4 with HCl. Okay, HCl gives you. So what happens? It forms KCl. Okay, and this Mn will react with Cl to give you MnCl2 plus H2O plus 5Cl2. Okay, so after writing, so what it is, the answer, so what you have obtained, the reaction of KMNO4 and HCl, it results into, so out of this. Okay, so what is happening here? Yes, so there is a, so this will be +7. Okay, +7. The charge is +7. And here, what is the charge of Mn? This is -2. This will be +2. So this is getting reduced, decrease in oxidation number. So decrease in oxidation number is nothing but your reduction. So reduction of Mn in KMnO4 and production of Cl2. So this is D. The correct answer is D. Next, one of the following has both positive and negative oxidation state. So from the rules, okay, now suppose you don't know which is having, okay, so what you do, try to solve all the other options. Now you know in free elemental state, what is the oxidation state of Na? It will be 0. Okay, it will be 0. Then He is also is a free elemental state, so it is also having a 0. Cl, then this F, okay, F fluorine also has only one oxidation state, that is -1. So it is Cl. So Cl will have both positive as well as negative. So Cl, it will exhibit in -1 as well as +1, +3, +5, and +7. So these are the oxidation state in which it will show different positive and negative oxidation states. So Cl is the element. So next, so the correct answer is B. Next, what is the oxidation number of the elements in the free or in uncombined state? Yes, what will be the oxidation state? B, correct. Yes, others? What is the oxidation state? It is 0, right? From our first rule, whenever the elements are present in free or in uncombined state, it will be 0. Okay, we'll go to the next one. Oxidation number of hydrogen in NaH, CaH2 and LiH respectively is. Yes. So these are what? These are examples of what? These are metal hydrides. Solve this. Metal hydrides. In the metal hydrides, so whenever you have metal hydrides, what will be the oxidation number of hydrogen? Yes, it will be -1. So solve it. How it will be? NaH. NaH. So sodium will be +1. This will be -1. So it will be +1. So it will be -1. Then in case of CaH2, Ca is what? Ca is +2, right? So each hydrogen is what? Ca is +2. There are 2 hydrogens, right? So each hydrogen will be -1. So again -1. Then LiH. Lithium is +1, hydrogen is -1. So the correct answer is what? -1, -1, and -1. D. Okay, D is the correct answer. So you have to solve it according to the rules. Yes, the brown ring complex is formulated as Fe Fe penta aqua NO. Okay, nitric oxide in the bracket SO4. So this is a complex. Okay, this is a complex. So you have to find the oxidation number of what? You have to find the oxidation number of Fe. So how to solve this? So Fe, this is a complex. Okay, it is a brown ring complex. So NO and SO4. So what you have to find? This Fe. So write it as X plus. Okay, X plus. So each this water molecule is 0. So it will be 5 into 0. Okay, then plus NO will be always in +1 state. Okay, NO ion will be +1 state. So this will be +1. Then into SO4. SO4 is what? SO4 is what? SO4 is -2. Okay, so it will be into -2. So this will be X. So the overall it will be +1. So Fe will be in +1 state. A. Okay, so it will be A. A is the correct answer. So you have to write the charges and solve this. Okay, you have to write the charges of all the oxidation numbers you have to write, and then you have to solve it for Fe. So keep it as X and then you proceed. So next, in which of the following reactions there is no change in oxidation state? Okay, there is no change in oxidation state. in which, so solve this, try to solve, write the oxidation in this. Yes, write the oxidation state. So after, so there is no change in oxidation state. So it is, I'll give you the option. It is C. Okay. Why? Because in after what you have to do, so you have to write the oxidation number. You have to write the oxidation number for each. Okay, each reaction, and you see whether it is going change in oxidation state. Okay, if there is any oxidation state, the correct answer is here. Okay, there is no change in this particular, because this is example of double displacement reaction. Okay, it is an example of double displacement reaction. So all the atoms are present in same oxidation state in reactants and product. If you see this, okay, if you see this, if you try to write the oxidation number in for this, all the reactants and products, they have, there is no change in oxidation state, while the other three examples are the examples for redox reaction. So solve this, okay, solve this and you'll get it. So you have to just, the thing is what you have to write the oxidation numbers for each of this reaction, and then you have to C, which is not going any change. So the option is C. Next, the oxidation states of sulfurs in the anions SO3 2 minus, S2O4 2 minus, and S2O6 2 minus follows the order. Okay, which is greater? So what we'll do, we'll solve this. Which are the three? First is SO3 2 minus. So XS is plus. Okay, unknown. So how many oxygens? 3. 3 oxygens into how many? Minus 2. The overall charge is minus 2. So it is X equals to minus 2. So X is equals to what? 4, right? So this is 4. Next we'll solve. Next is for S2O4 minus 2. So how many sulfurs are present? 2. So write it 2x. 2x plus how many oxygen atoms? 4. 4. So each oxygen atom is minus 2 equals to minus 2. So this is 2x 4. Okay. This equals to, what will be the answer? Answer, just see. Yes. Next, S2O6 minus 2. Okay. Yes. Try solving this. So this will be 5. Okay. So for this, it is 4, 3, and 5. So which is greater? S2 greater than this. So the correct answer is B. Okay. The correct answer is B. Okay. So this is the way you're going to solve. So whenever oxidation states are to be calculated, so calculate and then try to solve this. Okay. So next, types of redox reaction. What are the types of redox reaction? So decomposition reactions. So breakdown of a compound into different compounds. So decomposition is nothing but breaking down of a compound. So when you, so example AB, if there is a compound AB, it breaks into what? A and B. So example is this. Okay, 2NaH giving you 2Na plus H2. So this is example of decomposition. Decomposition is breakdown. Next is combination reaction. Okay, combination of two compounds to form, okay, combination of two compounds to form a single compound. So example, A plus B giving you AB. Okay, so this is example of combination, combining of two compounds. So the example is Fe 4Fe plus O2. Okay, giving you 2Fe2O3, giving you 2Fe2O3. So this is example of combination reaction. A plus B giving you A, B. Then displacement reaction. Displacement reaction is what? It is an atom or an ion in a compound. It is getting displaced, or it is getting replaced by another atom or ion. So it is in the this is the type. Okay, it undergoes X plus YZ. Okay, these are the reactants giving you XZ plus Y. So what is happening here? An atom or an ion in a compound is replaced by another atom or ion of another element. So it is undergoing displacement. You can see the reaction copper sulfate plus zinc giving you copper plus zinc sulfate. So here copper sulfate is a compound. So from this compound, which is the element getting displaced is copper. So zinc sulfate, it gets attached. So this is displacement reaction. Displacement reactions are of two types: metal displacement and non-metal displacement. Metal means what? In which metals get displaced. Non-metals will be having in which non-metals, one of the atom or ion in a compound is replaced by another atom or ion of another element. Okay, so that is for non-displacement. So this is example for metal displacement. Next is deep disproportionation reaction. So disproportion reactions are nothing but the reaction, okay, in which single reactants is getting oxidized and reduced. So this is P4. So P4 here, if you write the oxidation state, okay, so this will be 0, and this is having oxidation state of so it is showing different oxidation states. Okay, it is showing different oxidation state. So the values of phosphorus, okay, the phosphorus, it will undergo, so it is a single reactant which is oxidizing and it is undergoing reduction. So there is a change in oxidation number. So it is change in oxidation number. So disproportionation is nothing but a single reactant. Okay, the reaction in which single reactants will undergo oxidized and reduce. It will undergo oxidized and reduce. Next is this question. Okay, next question. The more positive the values of E naught, the greater is the tendency of the species to get reduced. So using this standard electrode potential of redox couples given below, find out which of the following is the strongest oxidizing agent. So more the positive values, okay, more positive the value of E naught, the greater is the tendency to species to get reduced. Okay, so your metals which have high value, so metals with high value of reduction potential is good oxidizing agent. So the metals which are having higher reduction potential, okay, this E naught values are nothing but it represents the reduction potentials. Okay, so it is said to be a good oxidizing agent. So here, which is having the more value of E naught, it is Ag plus Ag, right? So which is the correct option? The correct option is D. Okay, why? What is the reason? Because the more the value, more the positive value of E naught, greater is the tendency of species to get reduced. It is a strong oxidizing agent. So the correct answer is D. Next, E naught values of some of the redox couples are given below. On the basis of the values, choose the correct option. So these are some of the values of E naught. Okay, E naught is what? It is the standard electrode. Okay, it is a standard electrode potential, or the redox potentials of different elements are given. So here what is happening? You can see Br to Br. Okay, so it is having what? It is having the highest value. So what is happening? It is having the highest reduction potential. Okay, it is having the highest reduction potential value. Whereas you can see for copper 2 plus by copper, it has a lowest. So this is the highest. This is the lowest. Okay. So therefore, which will reduce? Which will reduce? Cu. Okay. So D option. D option will. So that is copper will reduce Br2. Okay. How it will reduce? So if I write this reaction, you will come to know. Okay, so Cu will reduce Br2. So you know Br2 is 0, this is -1. So it undergoes, so this is increase increase in oxidation. So it will be oxidation number, it is oxidation, and this will undergo reduction. Okay, decrease. So this is a example of what? This is an example of standard reduction potential. Okay, higher the value, okay, more it will reduce. So next, using the standard electrode potential, find out the pair between which redox reaction is not feasible. Okay, not feasible means what? The reaction, it does not undergo that reaction. So E naught of some of the elements are given. Okay, you can see here. So E naught, okay, E naught of Fe 3 plus 3 and Fe plus 2 is what? 0.77. Then E naught of Ag plus and Ag, this is 0. Plus 0.84 volts. Okay. So the reduction potential of Ag plus 2Ag is easy than that of reduction potential of Fe plus 3. Okay. So the answer here is D. So this is, it will undergo, it is not feasible. Find out the pair which is not feasible. Okay, because it is having higher values. Okay, one should, one of the reactants should undergo, it will have more value and one will undergo less. Okay, one of the E naught value. So one reactant should have E naught value less and another should have more. So this reaction is not feasible. Okay, so Fe plus 2 reduce Ag plus and Ag will not reduce this Fe plus. Okay, Fe plus 3. So the correct answer is D. So based upon this standard electrode potential, you are going to find which of the reaction will be not feasible. Okay. Oxidation number of N in HNO3 is, yes, HNO3. Yes, find out what is the oxidation number. Plus 5, yes. Others, is it right? Plus 5. H is 1. Okay, plus X plus 3 into minus 2 equals to 0. Solve this. Yes, after solving, what you're getting? Plus 5. Okay, correct. So plus 5 is the correct answer. Next, the oxidation state of osmium in OSO4. So OSO4, OSO4. Yes, oxidation state, how we'll write for OS? X plus 4 into minus 2 equals to 0. Yes, calculate it and tell me the right answer. Plus 8. Plus 8 is the correct answer. So solve this, you will get the answer. Okay, plus 8. Next, the oxidation state of Fe in Fe3O4. Okay, Fe3O4. So you have to find the oxidation state of Fe. So how many atoms of Fe are there? 3. So you have to write 3x plus 4 into minus 2 equals to 0. Okay, 3x. So x is equals to what? What is the answer? 8 by 3. So this is the correct answer. Okay. So this is the way you're going to find the oxidation state. So whichever you have to find, you have to write it as x. So you, in this case, how many Fe were there? 3 Fe, right? So you have to write it as 3x. Sulfur, phosphorus, sulfur, and chlorine undergo disproportionation. Okay. Disproportionation reaction means what? Disproportion reaction. What did I say? Disproportion, in which a single reactant will undergo oxidation and reduction. Okay. So it undergoes disproportion reaction in which medium? Okay. It is B. Okay. The correct answer is B. Remember this. So disproportion reaction are carried out in alkaline. So in this case, where sulfur, phosphorus and chlorine is taken, okay, sulfur, phosphorus, and chlorine is taken, it will undergo disproportionation in alkaline medium. Okay. Next, which of the following element does not show disproportional reaction? Okay, or it does not have that tendency, disproportionation tendency. So remember, what are these? All are halogens. Okay, all are halogen, but only this fluorine. So it is a highest electronegative element. So as it is a highest electronegative element, it will not show any disproportionation tendency. Okay, so it is C. So others, it will show disproportionation tendency. Means what? It will show different oxidation state. It will show different oxidation number. It will show plus positive as well as negative. It will show positive as well as negative oxidation numbers. But fluorine, it will always show. So it has, it does not have that tendency. Disproportionation tendency is not shown by fluorine as it is highly electronegative element. Next, in the compounds KMNO4 and K2Cr2O7. Okay, in the compound KMNO4 and K2Cr2O7, the highest oxidation state is of the element. Now we have to find the oxidation state in both the cases. So KMNO4. So oxidation state of KMNO4, K is what? It is 1, right? M, we don't know. Plus, how many oxygen atoms are present? 4. Each oxygen atom is -2 equals to 0. Okay. So it will be what? Yes. It will be +7. So KMNO4. Then next is K2Cr2O7. So each potassium is 1. So it is how many? 2. Okay. 2 into 1 plus how many chromium atoms? 2 are there. Plus how many oxygen atoms? Minus. So 7 are there. Each oxygen atom is -2. So 2. Okay. So plus 2x minus 14 equals to 0. So solve this. So it comes to 6. So which is the having more? Mn. Okay. Base chromium or Mn, it is Mn. So Mn, manganese. Okay. Manganese will have, so it is +7. So it is having highest oxidation state. In the oxygen difluoride, okay, in the oxygen difluoride, the oxidation number of oxygen is, oxygen difluoride is oxygen OF2, difluoride, okay, F2. The oxidation number of oxygen is, so each fluoride is what? -1. So you can just substitute X plus, okay, fluorine atoms is 2, each is -1 equals to 0. So X, what it will be? It is +2. So it is +2. So this is the correct answer. Okay. C is the correct answer. In which of this compound does manganese exhibit higher oxidation number? Okay. So we have to write the, we have to find out the oxidation number for each case. Now MnO2, X plus 2 into -2 equals to 0. So X is equals to 4. Okay. Then Mn3O4. Find out. Yes, please solve. So it will be 3x plus 4 into -2 equals to 0. So substitute this. I'll give you KMO4. Okay. So it is 2 plus x plus 4 into -2 equals to 0. Then MnSO4. Okay. X plus, this is what? S plus minus, okay, so 0. So this will be 4 into minus 2 equals to 0. Yes, solve it and see. Yes, solve this and see. It will be yes. What is the correct answer? So, okay, C. C will be the correct answer. C will be the correct answer. So it is. So it is C. Okay, C will be the correct answer. So these were some of the questions which were related to redox reaction. So, okay, remember all the definition in terms of oxidation, then in terms of oxygen, hydrogen, electronegative element, electropositive element, okay, electron transfer, right, in terms of oxidation number. So remember all the definitions. So based on this, then again, oxidation number, okay, oxidation number, remember the rules. Rules are very important. So please go through all the rules and try solving this. Okay. So thank you for attending. We'll meet tomorrow. Okay. Thank you, students.
Ma'am, tomorrow we don't have class. Monday we have class.
Monday. Yes, sir. Monday. We'll meet on Monday.
Yes, ma'am. Thank you. Thank you.
Thank you, students.